literally this one. Yeah, people are coming back. So, Dr. Abasisi, yeah. Here today.
Yeah.
You have your laptop there.
Yeah, I'm trying to see if I can install my SPSS on my laptop again.
SPSS.
I have it on my hard drive.
Okay, no problem. Let other people connect.
Okay. Okay.
But this lady has been out since, so all those Blossom didn't even connect today. This lady, Bridget, she was around.
Okay.
So just wait for that people to connect. Some people find it difficult to connect.
Network is quite can be difficult.
Dr. Taiwo, Dr. T, unmute yourself. Dr. Taiwo. Yes, I'm here. What of Shegun?
Joel is back.
Yes, okay. Because I know that he was connected the other time. Okay, maybe he's trying to connect back.
Yes. He's going to connect back.
Okay, that's great. Who is using Techno Canon?
That's a strange name.
Yes,
it's me.
It's me. I'm the one.
Joel.
Okay, Dr. Abasi. Okay.
I'm the one.
But we have Isaac. We have Isaac up there.
Yes, I'm just checking on something.
He's the one. He's the one
I'm the very one. I'm the same person. I'm just checking on something.
No problem. No problem.
It's not double personality.
Yes, there are some people now that they just want to connect. They think maybe we are not serious here.
They want to look smart.
Yes. I don't. If I can allow somebody, even if you do better, not that you just come and dabble into people that pay. If nobody pay for it, no hold. That's just it. If nobody pay for it, we know. So,
but no sneaking. People should not sneak.
I was looking at the screen.
Whether I can do it. Yes, I know. It's Disraeli. Yes. It's Disraeli that said that. Disraeli, the former Prime Minister of UK.
Oh, yeah.
Kinds of lie, damn lie, and statistics. Because he was a prime minister now. Many people will say, research has shown this, and they put money, and the money drown, nothing happened. All those research that they tell lie. You know, it's not everything you quote that is correct. It's not everything that. Look, me, I don't quote. What I do is I look at your research and your methodology. I don't need your conclusion. I don't need your conclusion and your discussion. If I see the result, I can get my own something from your result. I can get my own conclusion from your result. And get your methodology, I see the result. I get you. But you conclusion follow that this is what you concluded. Because many people misinterpret results. Okay, I think we will continue. Yes. Where is this? Yes. Okay, before we go, hello, if you remember, are you there? Ugo, are you there? Ugo.
So I'm here, sir. I'm here,
yes.
sir.
You know, you were asking, this, can you see this graph I show now?
Yes, sir. Yes, sir.
That's the last thing I want to show you.
The grand mean and the individual group means.
You will see, I explained it, was it yesterday? But
yes, sir, you did.
We try to look at the last thing we did, when we did the post-hoc, it shows us the difference between the placebo, when you minus it, between the placebo and low dose is 1, the mean, the difference is 1. Between the placebo and high dose is 2.8. Between the low dose and high dose is 1.8. That is what it's showing here. The mean.
Oh.
Yeah. The gram mean is the dotted line, the gram mean, which is 3.4. So the green is showing the the placebo. Their mean is 2.2. Can you see where it is now?
Yes.
2.2, the mean of low dose. Can you see 2.2? And the 3 of them have value lower than the mean, 2 up above it. Then the mean for for placebo rather, the mean for low dose is 3.2. Can you see now? And then look at it.
Yes, sir.
3.2. 3 up below the mean, 2 up above. The mean for high dose is 5, if you remember. And this is the line.
Yes, sir.
And 1, 2, 3, one person has a value along the mean, 2 up below, 2 up above. And the gram mean is the dotted line, the gram mean, which is 3.47. You know, the gram mean is more than both the low dose and high dose, but it's not that both is higher than that of placebo and low dose, but not up to the high dose. Can you see? This one is just showing the relationship. This B1 is the difference the mean of the low dose and placebo, which is 1. Yes, if you run it as regression, and the regression coefficient B1 would be 1. Well, so if you look at B2, is the difference between the low dose and the high dose, and which is 2.8. If we run this as regression, the regression coefficient will be 2.8. So that one, don't worry. We'll do the regression later. I will do it, but let's just stop here and now go to factorial ANOVA. So it's another slide I want to share. Some factorial ANOVA. Yes. Yes, share. Yes. You know, want to quickly look at factorial design. When I experiment, I'll be using, sometimes you encounter experiment. It's because the people that develop ANOVA over time are people who are doing experimental research. But however, it's useful in any situation, either in observational. So, but most of the languages, that's why the word dependent, independent is common with experimental research, and you'll be hearing something like that in ANOVA, independent, because the word being used mostly by experimental researcher. Now, when an experiment has 2 or more independent variables, it is known as factorial design. It is because independent variables are sometimes referred to as factors. That is, you say, what are the factors, determinants, all those exposure variables, they are called factors. So when you, in this one we just did now, we just finished, it's one way ANOVA, it's one factor ANOVA, because the only factor is the dosage of, is, well, you can call it, the only factor is giving placebo, giving, what do I call it? Viagra. Viagra is the factor. The outcome variable is libido. If let's say we introduce another thing, let's say, okay, apart from the dosage of Viagra, we have black and white. That black and white, which is either the race, you can call it race, will be another factor. Yes, I'm now. So it will not be the Viagra, the drug, and the race. That will be 2 factors. And when you can have 3 factors, You can have 4 factors. You can have, they're becoming more complex as you are becoming many factors. So whenever you have more than 1 factor, it is referred to as factorial ANOVA. The type of factorial design we look at, we have independent factorial design. That is the independent variable. There are many of them. Just like the way I just give an example now, race and the drug. In that case, there are more than 1 independent variables. That is factorial, independent factorial design. There is repeated measure factorial design. Several independent variables, but the same participant. Now, when we say you did, maybe it's the same participant, you gave different thing. It's different from when you have different participants. Look at in this case now, you have this group, 2 placebo. The group that took placebo is different from the group that took low dose. It's different from the group that took high dose. Imagine, imagine you say somebody should go and perform as placebo later you mention the libido. The same person say come, we have take low dose. You go and perform, you measure the libido. You take later, another time take high dose, you measure. In that case, you are giving this different thing, dosage bets, the same group of people. That is several, that is repeated measure. We have mixed design also, where there's a combination of independent group and repeated measure. That's mixed factorial design. When one uses ANOVA to analyze a situation in which there are 2 or more independent variables, it's called factorial ANOVA. I've said that. Factorial ANOVA, for example, the 2-way ANOVA is conceptually similar to 1-way ANOVA. The concept is similar. It's just some little adjustment you make. That is, we still find the total sum of square. You remember this? You see, that basis for understanding ANOVA is that thing. That was why I was telling you to understand the level of variances, the variance within total variance. That is the basis for understanding ANOVA. And it's still the same thing. So you still find the total sum of square and break it down into variance that can be explained by the experiment and variance that cannot be explained. However, in 2-way ANOVA, the variance explained by the experiment is made up of not 1 experimental manipulation, but 2. If there are 3 factors, it will be 3. Now, therefore, we break the model sum of square into something is disturbing us. Who is that person? It's Prof. O. Now, so you have to break because the model, the one explained by the model, that is the variance, the one we call variance between the numerator. You have to break it down into the groups. So if you have 2 factors now, factor A, factor B, so you'll be able to break it down into the sum of square. That model will be broken down to sum of square for factor A, that's SSA, sum of square for factor B, SSB, and also interaction. There is another one that is due to interplay of both of them. That is A times B. That's just the logic. Look at pictorially. If you partition or experimental variance into component comparison, look at this. This is total variability. Variance explained by the model, which is the experiment, I call it, then unexplained variability. The unexplained variability will now partition to variance explained by A, because there are two factors. Factor A, variance explained by factor B, and the variance explained by the interplay of factor A and B. I have an example here. Don't mind me, most of the example I have is from psychology. Most of my, some of the inspiration I got from statistics is from one Andy Field. The guy is a psychologist. He's a I think he's a British psychologist. So some of the examples I'm using is what example I got from him. Most of my inspiration from statistics is from Andy Field. As most of the example I use here is from Andy Field. You see, an anthropologist was interested in the effect of alcohol on male selection at nightclub. This is an example. Somebody just, okay, the effect of alcohol in mate selection. That is, if you go to club, what type of either male or female you selected. When you say mate, can be person on opposite side. How attractive are the people you selected? You want to see if by the time somebody that take no alcohol is able to get more attractive people than the person that didn't take alcohol or take little, or the person that take more. You want to see the effects, because normally people like attractive things. When you get people that go to club, men look for ladies that are attractive, and ladies also look for men that are attractive. So does the alcohol affect their judgment? That's what he said. Our rationale was to have that after alcohol has been consumed, subjective perception of physical attractiveness will become more inaccurate. He called it beer Google effect. She was also interested in whether this effect was different from men and women. I'm just explaining so that you can understand. You don't actually need all this one, but just for you to understand the data I want to use. Because anything can fit into it. Even medical, anything can fit into it. So she now picked 48 students, 24 male, 24 female. Can you see? That's a factor. Sex is a factor now. Can you see one factor now? 24 male, 28 female. She then took group of 8 participants to nightclub and gave them no alcohol. Participants perceived placebo drink of alcohol-free lager, 2 pints of strong. So we have 3 group of people. One did not take alcohol. Some people took 2 pints, then 4 pints. So you have 2 factors now. The pint of alcohol, just like the Viagra we talk about, the pint of alcohol, there are 3 levels. No alcohol, 2 pints, 4 pints. Then that's one factor. Another factor is the sex, male or female. So this type of thing, you are now trying to, at the end of the event, she took a photograph of the person that the participant was chatting up. She then got a pool of independent judge to assess the attractiveness of the person photograph. The attractiveness is a score. They now give, okay, this one score on a 1 to 100%. What is the score? This person is very attractive. This one. So what you have there now is quantitative score, which is based on attractiveness. You may say that it's subjective, but that's not the issue. Now the issue is you have score here. You have score. Can you see now? We have 48 total. Out of the 48, the people that took, we have 16 no alcohol, 8 male, 8 female. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Can you see? 8 male, 8 female, no alcohol. 8 male, 8 female, took 2 pints of alcohol. 8 female, 8 male, 4 pints of alcohol. So virtually you can say that you have, if you have to use these 2 factors, you have 6 groups. Yes, Anna. If you have to use male and female, it's 2 groups. If you have to use the level of alcohol, non 2 pints, 4 pints, you have 3 groups. So when you multiply 2 by 3, you have 6 groups. Now, what do we do? You can calculate the mean for each of, can you see? Average is the one put down. Average for each of the group and the variance. Then you can calculate the grand variance. That if you add all the 48 together, you can calculate the mean, grand mean, rather, this grand mean. If you add all the 48 and divide by 48, give you the grand mean. Now, you know, if you want to now, you remember, we have two factors. Look at what was done here. This one just an illustration. You know, it's doing that I usually do this for people to understand. This is covering it. But look at it. The first one is total variance is showing. The first one is showing. The thing is too much for this thing that it's not showing everything. Don't worry. I want to do it very well. The thing aside. Anyway, without even wasting, okay, I think that's.
Sorry, 48 was showing. The 48 row.
No, but the total is not showing. I've dragged it, don't worry. It's total that was not showing for me. Yes. The total is showing now. Can you see? No, the total is showing.
Yes.
Yeah. What this one is just showing is that, though the way I arrange this one is a little bit different from what I arranged the other one. The first one is the total variance showing. If you look at it, look at the bar X double bar. It's double bar I have there. Is showing the total variance, right? That is, the first column is to remove the grand mean from each value, or the 48 value. You know, when you square it, it gives you the total variance. That's the highest figure there. The second set of this thing is to remove the grand mean, double bar, from the group mean. You know, if you remember, how to recognize that one is that for each set, it will be the same. For each set, can you see? For each set, it will be the same. For each, you know, there are 6 of them. Can you see? Each 6 group. For each group, that variance, the deviation will be the same. And when you square it, it will be the same for each set. That, we know that that is the variance between. The one that measures. So you look at what it does is to look at, remove the grand mean from the group mean for each group and square it. The third one is the variance within each group. Is to remove the group mean for each group from each value, and that is this. If you add these two, the last two, the variance between and variance within, the variance between the middle and variance within at the end is equal to the total variance. And that is what I've shown here. If you look at the summation, the total sum of square is this. The modest sum of square is the one in the middle. And the residual sum of square is this. It has not ended there. You know, because there are two factors. You are just done for total now. That total, inside that total, you need to split it into the two, because there are two. Ugo, what is it?
Please, sir, you mentioned something. You said residual sum of squares.
Okay, sorry. It's my language. Residual here just means within. Maybe I should put within, variance within, because we are used to it, because it's the same language for regression. And let me just put within. Let me change to within. That one between.
Okay.
Yes, I mean now. This is between. If you not confuse you, within. Yes, I mean now. Variance within.
Thank you, sir.
Yeah. So, but when you see anything like that, you know, so we have just looked at separated the variance between and variance within. But that variance between, which is the model, the contribution is not, you have to break it down. You have to take the main effect of the sex, which is gender, the main effect of alcohol, and the interaction effect. So if what you do, can you see the logic? Instead of that, you now have a separate table. This table now, what it does, it will collapse all the female. Forget about whether they took alcohol, took alcohol or not, or 1 pint or 4 pints. You collapse all the female, you collapse all the male. You calculate their mean. Do you get the vision now? Then here, you collapse those people. You want to know the effect of alcohol. You collapse all the people that have no alcohol, 2 pints, 4 pints, irrespective of male or female. Can you see now? You are separating the two effects. The first one is looking at the main effect of gender. The second one is looking at the effect of the alcohol. If you repeat the same thing, can you see? This first one is for gender, this one is alcohol. Can you see that? Repeat the same thing. You'll be able to separate the effect. The same problem is happening here. Don't worry. Is this too technical? Somebody
no, it's clear. No, it's clear.
It's very clear. It's,
I understand what you.
If anybody that, if you understand what we have done before, for the people that are maybe for the first time, they may find it, but it's the same logic. What we have been discussing since yesterday, the same.
Okay, it's the same calculation you're doing.
The same,
that is for each of them.
Same logic, yes.
Between and with. Okay.
Within, yes. So, but this one now.
So this one now is which, like this particular table now.
This one is doing the between. Is what is trying to do is to look for the mean.
Between.
You want to see the deviation of the mean of age of the each sex from the ground mean. This is between. It's only the between is doing here. He's trying to look for the main effect because it's the between that incorporate both the effect of the factors. So what it does is that when you know the mean for, if you do the previous slide, you can see male, female. You calculate the average mean score for female, mean score for male. Here,
male.
Effect of alcohol, mean score for none, mean score for 2 pints, mean score for 4 pints. So what you do is that you now remove the difference between this mean score and the grand mean. So the grand mean we already seen before. So all you need to do is for each of them, you remove, for each of this score, you remove, each of them, you remove the mean score for each group from the grand mean. The same thing for alcohol and this. That is what it, if you look at it, bar S minus double bar X. It's the same thing you are doing for gender and this. So when you do it, it's the main effect. The sum of square for A for gender is 168 on this. If you go and check.
And that's what you got from that table.
Yes. Yeah. If you look at the first one, Then the second one, the alcohol is 3,332 point something. Can you see? The main effect of alcohol is this. The interaction effect. If you add the two together now, it's not T up to the variance between you calculated before.
Sum of total.
No, it's not total. There's some model sum of square, which is the sum of square between, which is 5,479. When you now come now, if you add the two, it's not up to. When you remove the two, whatever remains is the interaction effect of the two of them. Does it make sense?
Okay.
Now, if you now go further, you see, you now say the effect, each effect in the two-way ANOVA may infer an interaction effect has its own F ratio. So what you do is to, what is the variance for each, for sum of square A, for A is the sex F. Is this, for some of the mean, the variance for sex will be sum of square for sex divided by the degree of freedom. What is the degree? How many group of cells do you have? Two. 2 minus 1. 1. The degree of freedom is 1.
Okay.
So the variance is this.
Okay.
Then for B, which is alcohol, which is the sum of square for alcohol is this, and there are 3 groups. 3 minus 1, the degree of freedom is 2. So you know there are 3 groups of them, the alcohol, no, 2 pint and 4. None, 2 pint and 4 pint. So you have 2. When you divide it, it's the variance. For the interaction effect,
so how do you do the degree of freedom?
Yes. Even for that one also, you remember when you do constabulate 2 times 3, because the degree of freedom, 2 minus 1 times 3 minus 1 is going to be 2. Who is making noise?
I didn't get it. Sorry, I didn't hear it. So there was a noise in the back. I didn't get the last thing you said.
I've muted him. It's prof something. So before interaction, the variance for interaction effect, which is A times B, is sum of square for the interaction, which we have gotten before by removing this sum of square from the model. Then divided by the degree of freedom. The degree of freedom of interaction will be 2, because there are two groups of sex and 3 alcohol. 3 times 2 minus 1 times 2 minus 1. You know, it will form 2 by 2 table. The degree of freedom will be 2. So that's why.
So it will be 2 minus 1, 3 minus 1. Isn't that 2? Oh.
Yes, now that's why the degree of freedom is 2. So you divide by 2, the degree of freedom, it give you this. So now
and within
the residual, if you remember, the residual is one, which I said between one you calculated initially over 42. You know there are 48 of them, and there are 6 groups.
That's true.
Well, you 48 minus 6, so each of them will be 8 minus 1, 8 minus 1 in 6 places. 7 times 6 is 42, or 48 minus 2. The degree of freedom for that one 42. You get this. So F ratio for the 2 independent variables and their interaction can be calculated by dividing their mean score, their variance, which is the mean score, by the residual, which is this one. So just divide this by 83.1 residual, all of them by 83 by the residual. When you divide, this is for this one 2.03, for this one 20.8, for this one. So you can see if you go and check the critical value for the degree for the corresponding degree of freedom. Now you will see that for this one now, the degree of freedom is 1, and the degree of freedom is 1 and what? And 42. Want to check if they are significant. If we go to the, I'm sure these 2 are significant, but this one should be, I don't know if it's there, I can't remember, but if we check it, we go to see if it's there. The result is there anyway. Does it make sense? No, it's very simple.
Please, sir, can I go? No, in fact, I understand it. I just want to look at the slide before this one. I just want to look at the slide before this.
There's
a slide where you did some calculations.
This one?
No, backward. This one. Yes. This is what I want to say. Yes, I want to digest this interaction effect. How you? I know that you said
you remove the main effect from the model. The model is the total for the two factors and their main effect. So when you do the main effect for each factor, it's not still up to for the model for the between. So the remaining one is the interaction. So you calculate those 2 and now.
So what you did, sir, was that you did the sum of squares for gender, you did the sum of squares for the alcohol. So, but you had initially done that, the sum of squares. That's total for all of them, for the whole thing.
To separate model from residual. To separate the between from within.
That's where the terminology comes now.
Yeah, between within. So they are separated. So and it is the between you are splitting into 3. So once you have calculated for gender and alcohol, for you to know interaction, just remove the 2 from the between.
Oh, it's true. These ones are between that you split in 3 ways.
Yes, it's this between that. If you look at 5,004 and something, look at it. It's the between. Look at it.
Okay, I know that.
The model sum of square between is the one. So. It's just a logic, but once you just go and
What's
you
your
just go around.
basket?
Does this
Makes sense.
So any other question? Any other question? So that we go and run it. Just straightforward. Any other question? Because sometimes when silence is much, it may mean that it's confusion.
It's okay.
It's okay.
It's okay. Yeah.
Yes. Any other question, Dr. Baku? Is it clear?
It's very clear, sir. Thank you, sir.
Dr. Odusolu, is it clear?
Sir, just go ahead.
Okay. Because you were not around yesterday.
Just go ahead, sir. At least I understand bit by bit.
Okay, it's because you were not around. So somebody that even was not around, he has no gas. Maybe the thing was giving headache. And to be sincere with you, there was no way we can go back and be, because it's, this is the type of thing that you just have to be there from the beginning. Yes, I mean, unless you get up to bring you up to speed with that one before you proceed. So you will have understood it. Shegun, any questions? Is it clear? Shegun, is it not? Maybe it's not there.
Yes, sir. I understand, sir.
Okay, that's great.
Yes, sir.
Okay,
Clear, sir.
Okay,
yes, sir, it's clear.
That's great. Okay, let's proceed. If it's clear.
I'm here, sir.
Okay, that's great. Let's proceed. Okay, let somebody share that via Google effect. There's a folder, there's a file. Somebody should share. Who will share? Where is Jane? He has logged out. Okay, who will share? Dr. Taiwo want to share? Dr. Taiwo? Dr. Taiwo?
No.
That's what Mucho said. You want to share?
No.
Why? Okay, who will share with us? There's not one person that should be sharing. Dr. Anyaku can share them. Dr. Shegun, can't you share? You have your this in there now. Dr. Shegun.
So I'm using two different laptops. So I'm working on one where I'm taking the lecture on the other one. That's why I won't be able to share.
Okay.
Yes,
okay.
Sir.
Dr. Anyaku can share now. Share the
Google.
Yes, sir. Share the
okay.
Google effect.
Okay, sir.
Yeah. When you just do this, we explain, we close. So the other one will still continue tomorrow. We still have 2 more under the factorial, but it's worth it. Worth it. For the time. So is it delaying? If it's delaying, maybe Dr. Bako should share. Jane, we have been waiting for you.
Okay, my internet logged me out. You know, I'm in a village in Meduguri.
Okay, yes.
Near Sambisa.
I'm in Meduguri too.
Metropolis or you are in Mugono? How can you say Meduguri is not a village? Are you
it's near? No, it's near Sambisa.
Madam,
Is it Dr. Bako that says he's in
Empire?
I'm in Meduguri big time, madam.
If Dr. Bagada catch you,
yeah, big time.
You say you are in village in Meduguri. Okay. Let Dr. Bako share then. If Dr. Naku is not coming, if you can share via Google effect so that I can save time. Because I don't want to do it because you doing it also has to adding to yes, you understand it. I don't want to do it because I have it here also and do it better. I'll be doing all the other talking. Let other people also participate. Because if you have shared the other one, you will have saved them in the same place. Where you save the Abiaga, that's where the Google effect. Bare Google effect. Or maybe
enable me, I'll share it.
So you disabled me.
Okay, sorry. Okay, when I log again, sorry. I've enabled share.
Okay.
That's great. That's great. So now go to analyze. Can you see? No, wait, before that, if you look at it, everything, because there are independent groups, even though it's a factorial that many alphabet, they are arranged in series 1 to 48. So male, can you see all the male first better, all the male alcohol, no alcohol, 2 points, 4 points. Then the female follow, no alcohol, 2 points, 4 points. They are separate people. There's no repetition. So they are independent. That's why they are enter. And look at their attractiveness. Just okay, go on now. Analyze. So go to general linear model.
GLM. GLM.
Yeah, univariate. Univariate. Don't worry, tomorrow I will explain that GLM and why it's univariate. Click on it. Click on it. Yes. So dependent variable is attractiveness. Is the attractiveness. Yeah. Now the alcohol
factors.
Yeah, thank you. Move both of them. Just select both of them. Gender and alcohol. Select both.
They are the two
both
factors.
Both of them are both factors, yes. Yeah. And you can move one by one, no problem.
No,
Control A, if you say Control A, if you select both of them. Control A.
Okay.
If you do Control A.
Or you can hold down your Shift key, your Control key, and then you select.
Okay, you can do it one by one. Put
gender. One by there is very soon.
Move gender and move gender, then move alcohol. One by one.
To fix.
To that place,
fix factors. To fix factors. To the factors.
Yes. To fix factors.
Why fixed?
It's fixed factor because they are not. If you look at, they are categorical.
Okay.
Yeah, they are categorical. They are not something that just change. It's not random. Okay.
Okay.
Now, you want to. If you want to, there are many things. If you go around this one, we get some out. But you know, instead of wasting time, you know, all this issue of post up, all those things, you can do it at the same time. The while running it, go to contrast. Go to contrast. So, you know, choose, click on that none. Click on alcohol first. Click on alcohol. You know, do you need contrast for sex here? Or which one do you need contrast for? I want to ask if you are following some of the things you have been doing. Which of them? Do you need contrast for both of them, or which one do you need contrast for if it's not both of them?
Well, we need contrast for alcohol.
Why alcohol? Why alcohol? Why not gender?
It's independent variable.
Both of them are independent variable.
Alcohol has 4 factors.
Okay. Alcohol has 3 factors now.
Yes, after all, 3 factors. Yes.
No alcohol, 4 pints and 8 pints.
Okay. No 2. You don't need 2 male and female. There is no contrast now because if you can combine male, there is the alcohol. The other no 2 pint and you can. There are 3 ways you can combine them. Can you see? That's what you need contrast for. So that you click on it and now click on that contrast none under the arrow. Click on the arrow. No, it's put MAT. No, yes, MAT. If you remember, this none 2 pint, 4 pint is like the placebo low dose and high dose. If you look at
high
it,
dose.
So that's, if you look at it, MAT we use the other time. Click on change. Click on change as you click on change. Can you see now? It has put MAT in front of alcohol. That gender you don't need contrast. Alcohol has put instead of known that was a default. It has put MAT there. That's the contrast. Continue. Now put plot. Plot.
Okay.
Put gender. Move Okay, move aqua. Yeah, move aqua. No, first of all, move aqua. You can move both of them anyway. Move aqua.
Horizontal axis.
Horizontal axis, yes. Click, move it now. Add, click and add is down. Add, that's add down.
Plots.
Add, click on add.
Okay, add. Okay,
yes,
add.
I need to move it.
Sorry.
Click on gender. Again, no, you have moved aqua now. Click on gender again.
Okay.
You want him to plug graph for gender also. Click on it. Move it now. Move it in.
Move to horizontal.
Add also. Click on aqua also again. Move to horizontal. Move to horizontal. Yes. Click on gender. Click on gender. Move it to the other line, separate line. Move it on separate line. Add. Let's see. Add. I'm looking for the interaction. So what I've just done now is that I want him to plug graph for aqua for separately, plug graph for gender separately, plug graph for aqua and gender effect combination together. Continue. All those things, when you follow it step by step, they are not difficult. That's why SPSS is the easiest to learn statistics, because if you look at it, it has a well-developed graphical user interface. You cannot get this in Stata or any other one. No, you have to just be. You have to be.
So, Doc, do you have these steps outlined? Do you have these steps outlined in the module for today?
Yes, it's there. It's even in the module. Yes, it's in the module. All those things there, even the screenshots, they are there. Don't worry.
Okay.
Click on post hoc. Click on post hoc. Okay. Now, sorry. Okay.
We've done contrast now.
Yes. I just want to. Okay, we should not do post hoc. I just want to, so that you can see different result that comes out. Move.
No problem, sir. Let's do it.
Move both of them inside. No, wait. Move both of them inside. Let me see. Move both of them inside. Move. Yes. Click on. Which one do you click on? Just click on LSD.
LSD.
Click continue. No, what do you want Verforini for? Continue.
He wants to overcorrect.
Continue.
Okay.
Click on options. Just click on descriptive statistics.
Descriptive statistics.
Click on homogeneity test. Those are many things you can. If you want to know the gender, alcohol, this thing, you want to need the means of this thing, you can move them to this place. It will still show you the mean. Come here. Move gender, alcohol. Move them to mean display. Click. Move. Move the other one. Move the other one also. Let's see.
Okay.
Yes.
Interaction.
Compare main effect. There are many things that will confuse you. Okay, just leave it. Okay. There are two different ways you can. Okay. Click on this thing. Click on that LSD something down. But that's another way you can do contrast also here. Let's even click on Bonferroni in this one. They will give us two contrasts there because you can do. Click continue.
It will be very wealthy.
Click OK.
The table will be too much.
Don't worry. Don't worry. We say you don't need to interpret everything. Click OK.
Okay. Are we not seeing it?
Oh, we are not
seeing it.
No, share your this. We don't
have to share. I think
the output.
Share the output.
Okay.
The other one we are still seeing. We didn't see.
You should click OK. If you click OK, the output should display.
No, it will not. It may not.
So share.
New share. Do
You
new
have to
share.
reshare.
New share.
Yes.
If it's a Dr. Babagan something, it will show immediately. Is that the RAM is bigger?
It's showing now. Aren't you seeing it?
It's showing, yes, yeah. So let's go on. Can you see?
It's not.
Go on. Scroll down. Let's see. It will tell you 24 male, 24 female. The alcohol 60, 60, no.
Just scroll down.
Scroll down.
Scroll down.
Let's see. Wait. Let's be looking at it one by one. Test of between subject. Yes. You see this one now. Okay, so that it doesn't even confuse you. I want us to go and look at. Go down. Just like what Prof said. Okay, you see 11 tests, homogeneity of variance. Can you see? There is no significant difference in the variance. Let's see. Yeah, scroll down. Before contrast estimate. Yeah. Okay, before all this pairwise, scroll up. I want to go and scroll up first. Go before you take me to scroll up. There's a table. I want to go and locate this. Okay. I'm seeing something here. Scroll down small. Scroll down.
Excuse me.
It's after 9 now.
It's okay. Yeah, we'll close now. I'm trying to see if this is the main effect of contrast. Okay, go up. If you look at it, if you read, this is the total effect. If you remember, the residual was 83%. The sum of square residual. Go up. Just go up. Go up before this table of go up. Yeah, wait. In this table, I want to test between subjects.
Okay.
Yes. Model intercept. So corrected model.
Corrected model.
Then I'm looking for those. If you remember, corrected model. If you remember the model, the total model we calculated before, sum of square total. That was the value. If you remember, 5,479. You remember? If you remember for the gender, the main effect of gender is this. Can you see? The effect of gender is not significant. The overall total is significant. The gender, that is what they are saying, that there's no difference between male and female. If you consider only male and female in the way they choose attractive choose mate, yes, I mean, there's no difference. But look at alcohol. Can you see significant difference? If you look at it, remember the main effect of alcohol, that was the value we got. Look at it and look at it. Is significant, right? If you remember, the main effect of alcohol is 20.06 and it's significant. But gender alone is not significant. Interaction effect, if you remember, that is the sum of square we got for interaction effect. You see it is significant also. Does it make sense now? So what it's telling you is that alcohol alone, effect of alcohol alone is significant. Effect of gender alone is not significant. The interaction of gender and alcohol is significant. Does it make sense now?
Yes.
Then the two factors together is significant. Then you cannot know where the factor lies there. It even makes sense where the factor lies, because it's very clear that it's the alcohol that is causing it. It's not the alcohol, it's not the gender, it's not the gender. Let's go down. So go down now. Let's go to the graph. Let's go to those contrasts with it. These are the contrasts. Yes, go down. Let's go to the graph. Time is gone. We may see come back to it tomorrow, but I want to see the graph you plotted. It's coming up.
It's still processing.
Your RAM is too small.
It's very low.
Okay, sorry, I made mistake. Is this I wanted to plot bar chart? Is line you want to plot? Is bar chart I wanted to plot. This one does not make much meaning.
In fact, that's what I thought of when I was thinking, age.
It's batch A. What I forgot to, I used to change to batch A.
Sorry, what I mean, sex and
don't worry.
And
don't worry. Go to analyze. Dr. Anna, or just change that when you see that, you will see it immediately. Go to analyze. Go to analyze. Click on analyze.
Okay.
Go to general linear model. Go to the same place. Univariate. Everything you have done there. You are not changing anything. Go to that plot. That's the only plot I want to change. Go to plot. This is where there's a way you click. There's a way, click continue first in the plot. There's a place where it shows the difference between your own is not when I was plotting
you want to try options?
Is it option? Is it under option? Let me see. Click on the option.
Okay, it's not.
Okay, don't worry. Just stop sharing. No, I've run it before. I have the results. Just stop sharing. Stop sharing.
Okay.
Why not go to description?
Don't worry, just leave it. We'll do that one tomorrow. Don't worry. We'll do that one. Time is gone.
There's so many.
Yes, sir. Please. Yeah.
Look at it. I've already put it. Yes, look at it. The graph. Okay. If let's say is the batch A will put exactly what you did is exactly this. So though you will not get all of them because this is May effect aqua, the first one.
Oh wow.
May effect of aqua. This you can you see now the attractiveness reduces with 4 pints. Can you see drastically? There's no much difference between no pint and 2 pints. If you go and check we'll share it tomorrow. If you go and check our post hoc and contrast, there you won't see any difference between no pint and 2 pints. Just like the way placebo and low dose the other time. But you can see difference between each of them and the 4 pints. That's what makes
4 pints.
If you look at the effect of if you look at the effect of sex, there's no much difference between male and female. Can you see more and more different? If you now look at interaction, can you see the interaction now? When you split it, the male, blue, female, can you see?
Yes.
You see that the theme is less, the effect is more on male because the scoring attraction 4.
Yes.
Can you see that? Yes, the attractiveness is higher in female. You choosing. So the effect of the aqua is more on the female on the male. So this interaction you see here, this is a line graph, the way it crosses, same thing. So I think we can close here tomorrow. Because some people are already yawning.
So 10.
The video of yesterday.
Oh, so I didn't know that. I didn't know I was here. I didn't know that my this was on. The button. Okay. Sorry.
Okay, no problem. I think you have everyone go and rest. Go and rest.
Thank you so much. So at least I had a deep understanding. A deep understanding of this whole thing.
Thank you so much, sir.
So I will send the link to you with the video also, so that before something you can watch before tomorrow's session you can watch. And, okay.
Thank you, sir.
Good night.
Thank you so much.
Good night.
You're welcome, sir.
Good night, everyone.
Thank you so much, sir. God bless you. Good night, sir. Good night, everyone.
Good night, everyone.
Good night, everyone. Good night, sir. Bye-bye.